Yeah, Dennis. All right. If you're watching on YouTube right now, you have no idea what that's about. Okay, so our problem is we have a triangle with 4? It was 4, right? 4 circles on each side. And we're trying to make this triangle an equilateral triangle. In other words, we're trying to make all sides be equal. So this side, when it's summed together, should equal this side when it's summed together, should equal this side when it's summed together. It's like some crazy looking family crest from Russia. All right, so you had all the sides equaling 20. Okay, how'd you do it?
The first one was 1.
So top, starting from the top and moving clockwise. 1, 3, 7, 9, 2, 4, 5, 8, 6. All right, so let's add them up. 1, 3, 7, 9. So 1 and 9 makes 10. 3 and 7 makes 10. That's 20. Adding things up in interesting ways might be better than just doing it like 1 and 3 is 4. Okay, 4 and 7, that's 11. Carry the 1. Add 9, that's 20, right? 1 and 9 makes 10. 3 and 7 makes 10. Boom, done, right? So get creative. So we've got 5 and 9, which produces 14. Then plus 6, that's 20, right? And then we've got, let's do 8 and 1 is 9. 5 and 6 is 11. 9, 11, that's 20. Hope that wasn't too soon. All right, 20. Anybody top 20 for biggest sides? No? Okay, so that's one possible solution. Notice that this triangle, I mean, it's going to be kind of goofy when I do this, but like if I rotate it, we have the same triangle but with a different configuration. I would consider that the same one, right? Just because it starts with 5 and goes around from there, it's the same as this, right? So you might have had a similar solution where 1, 5, and 9 were your corners. Did anybody have any different corners than 1, 5, and 9 and they got maybe the smallest possible triangle? Or a different solution at all? Or did everybody get the exact same thing? Noah, go ahead. You didn't get a solution, okay. So what was your strategy? Like, how did you go about it? You just throw numbers down and see what happened?
Well, yeah, I was just kind of messing with them.
That's fair. Yeah, no, that's cool. That's cool. Are you guys still working on it? Nice. I like that. Bunch of nerds over there. All right. No other solutions? Everybody else got stumped? Is that what happened? Okay. Gosh, Jenna says yes with the head bob. Okay, cool. So while you're still working, I'll take a break to talk to you about some other stuff, and then maybe we can come up with some solutions over there. First things first. You might see these posters in the hallway. They were designed by Andrew, who is in Game Club. It says, "Do you think board games are boring? We can change that!" with 3 exclamation points. That's how you can tell I didn't make it. We have good games over here, including Dungeons & Dragons, Clue, the Office edition, which is still not a good game, but it's The Office, and you kids like The Office, right? It's all the rage, totally, right? There are 2 kinds of people. There's Office people and Friends people, and if you like Friends better than Office, you're a moron. All right, so 7 Wonders is an excellent game. You don't know what that is. Bad games. We have a bunch of nerds sitting around a table. That's not what we do in here. Chutes and Ladders is not a good game. I prefer Candyland for the worst game of all time. You literally draw the card. It tells you what color to go to, and there is no skill involved. It is literally draw the card, I move. That's it. It's not even like dice where it's fun to roll, right? It's still random, right? And then we have Hungry Hungry Hippos, which I think is a fine game, but Andrew doesn't like it. Anyway, it's in here from on Monday and Tuesdays from 3 to 5. Next week, we're planning on having pizza Tuesday, so if you show up on Monday, we can take your order, and then Tuesday we'll get pizza. Spread the word, nerds. We play card games and chess as well, so if you just like playing euchre or any of that crap, come on down. Also, this is a school-wide competition, but I figured I would make it self-development as well. I'm going to be posting these throughout the year. This is number 1. So it's called Split 25. You take the number 25, you break it up into as many pieces as you want. Like, for example, 25 can be broken up into 10, 10, and 5. We're breaking it up into a sum, right, of its parts. It can also be broken up into 2 and 23 or all the ones, right? So the question is, what is the biggest product? Product means multiplication, right? You can make if you multiply those pieces together. So this would be a very bad example, right? Because if you multiply 1 by 1 a million times, what do you get? 1. That's not a good example. The only thing worse than that would be like, oh, 25 plus 0, right? This one would get you 46, which is pretty dope. But this one, look at that, 100 times 5, that's 500. So if you can come up, so it says in the fine print down here, When you think you've got it, write out your solution, attach all your work, and turn it in by Friday, September 13th. That's not next Friday, but the Friday after that. For questions and to submit your solutions, see me in room G1. That's this room, ground floor number 1. The 3 best solutions, so the ones with the biggest results, will be posted in the hallway for all to see, your name in forever glory. For my students, so this is open to all of school, but for you guys, this will count as 1 self-development point if you have a submission. So if you make an attempt, right? Don't submit 25 plus 0, I swear to God, or any of the ones that are on here. And you have to write about it as well. 4 self-development points for a top 3 answer. Okay? Be sure to write about your solution. You have to answer, will your strategy work for any number? Why you think this is the best thing you can come up with, okay? If it's like literally I tried one time and it's like 24 plus 1, oh darn, right? We're probably not going to give you that self-development point. I'm going to lose that on accident. Oops. So actually try. Will your strategy work for any number? Why or why not? I need a written explanation, okay? Talk to me about your strategy. That's the thing. It's completely optional. You need 10 self-development points per semester. I'm already regretting making it that low, but here it is. At my last school, people were babies, and they couldn't find out how to do 10 self-development points. Actually, it was 20, and so I cut it to 10 for this year, but you guys are the opposite of babies. Hello. You got another answer. All right, so what'd you get, Jerica?
So on the top, I had 8.
Ocho,
And then
2,
4,
4, 9. All right, so let's add these up to see what she's getting at here. So 8 and 4 makes 12, 2 and 9 makes 11, 12 plus 11 is 23. Oh, new record. If it works, keep going.
Then I got 6,
6,
1,
1,
7,
7. Let's check her work. So we got 9 and 1, that's 10. 7 and 6 is 13. That's 23 all day. So now what? 5, 3. What else? Oh, 8. All right, so 7 and 8 makes 15. 5 and 3 makes 8. That's 23 all day. Is that the biggest possible answer? All right, let's break a rule. You're allowed to use, or you don't have to make all the sides work, okay? So here's the deal. What's the biggest possible side we could come up with? If we only had to fill this out, what's the biggest thing it could be? 9876, right? The 4 biggest numbers. So check this out. This is kind of fun. 9 plus 8 plus 7 plus 6. There's an easy way to add up consecutive digits. So check it out. Add up the out two. What do we get? 15. What do we get in the middle? 30. This works for any set of consecutive digits, right? So if I erase this and I go like 5, 4, 3, 1, 2, 3, 4, 5, 6, 7. Let's do 8. So if you add up the outside, what's that? 11, right? Add up these. 11, 11, 11. So we have 4 11s. How much is that? Isn't that fun? Gauss thought of that. He was asked in his like middle school math class. Gauss is a famous scientist / mathematician, like the big 3 in math. He's like one of them, okay? Gauss was asked to add up the numbers 1 through 99 because his teacher was like lazy that day, and he's like, here's your math assignment, kids. Good luck. No calculators. See me when you're done. And Gauss did in like 5 seconds, and the way he did it is he added up 1 and 99 first. What does that make? What's 2 and 98? 3 and 97. How many hundreds are we going to have? We're going to have about 50 of them, right? And there's going to be 1 in the middle, 51. So you add that on, right? And you're done. So 50 hundreds is what? 5,000? Add on 51. So 5,051 is the sum of all the digits between 1 and 10, or 1 and 100. Something like that. I'm probably wrong. YouTube's like calling me out right now, but that's off the top of my head. Gauss, smart guy. All right, so any other solutions? If you can come up with bigger solutions, bring them to me, okay? Whatever you got next hour, all right? Whatever that is, no one cares, right? You're doodling around, you're not paying attention in class, do this, right? That's why we have warm-ups, to distract you from the rest of the day. All right, put that away. Let's talk about the homework, part 2. All right, so we talked about this yesterday. Number 5 was -7. Okay, oh yeah, trade and grade, 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 trade and grade. We've got the other one too, we'll get that out in a second. We're going to talk about that in class. This was the homework from Monday? Monday? You didn't get it? Oh, good, okay. Yeah, the bottom 2 were self-development, right? And then these 2, if we graded them yesterday, I'm not sure or not, I gave you another chance to get them done. So now we're going to, All right, so negative 1711 is number 5. Remember, one of those points is an endpoint, the other one is a midpoint. So the way you set it up is you have a midpoint over here, and then one of your endpoints plugged in, but not the other one. This part right here is equal to negative 9. Boom, you solve. This part right here is equal to 10. Boom, you solve. Okay? That's where that came from. Number 6, same dumb thing. Midpoint is 4, 8. Endpoint is negative 6, 4. So negative, I plugged in 4 and 8 here again. So that's not the right answer. How embarrassing. So let's do it together. So negative 6 plus x divided by 2 is what we have here. So we add over, or we multiply by 2, we get 8. We add over 6. What's 8 plus 6? 14. So the answer is 14 there. That was convenient. All right, and so this is a 4. We multiply by 2, we get 16. We subtract the 4 now, and we get 12. Oh, that's kind of cool. We learned something new today, right? We only needed to add a 1, because our difference was what? I originally wrote a 4, and then I moved it to a 6, right? A negative 6, a difference of 10. So, of course, the answer was off by 10. And then here, I had a difference between 4 and 8, right? So my answer was off by 4. I had 2 before, and I got 14. Oh, that's interesting. Interesting. Okay, cool. Number 7, find the quarter way point between these two, okay? So here's what I did. I did it geometrically, visually. Okay, let me zoom in some more. Jenna's over there squinting. All right, so here we are. The distance between these 2 points horizontally is 8, right? Touch the screen and that happens. I touch the screen to do other stuff, it doesn't work. All right, I don't know. So the distance between these two, and I can't get my finger even close to this thing, so it'll activate, right? We have 2 over here for an x value, and we have 10 over there for an x value. The difference between 10 and 2 is 8. So that's the distance horizontally. Well, 8's divisible by 4. So I divide that by 4, I get 2. So that's a quarter of the way horizontally, right? Here, vertically, the distance is 4 because we're between 4 and 8. Well, luckily, 4 is divisible by 4, so I can find the quarter point. It's 1. So at 2, 1 is where the things are. If this was centered on the origin, but it's not, right here, that dot's at 2, 4. So I add on 2 to my x value, and I get 4, and I go up 1 to get 5. Does that make sense? Right? So this is way easier than doing it algebraically, right? Like, that's a pain in the butt, yeah. Oh, no. Oh, dear God. Okay, so you found the midpoint, and then you took the midpoint again. Okay, so that's the midpoint, and then the midpoint again would be 5 and 2 added together divided by 2, which is 7.5. And then 4, 7, 5. Oh, is that? Why are we adding 8 and 2? Oh, 8 and 2 are x. Oh, you added the x value and y value. That's what. Got it. Got him. Yeah. My advice, okay, because you're like, I don't need to do this. Why would I ever make this mistake? You will. You will. She made it. And she's like super smart, right? So like, you should do this too. Whenever I get a new problem, I label them like this. Because Lord knows you're going to screw them up, right? You're gonna. It's going to happen. All right. Number 8. Again, for self-development, if you got this one. Now I got to zoom out again. Sorry, Jenna. All right. Jenna, I'm planning on going to the eye doctor once my insurance kicks in for the first time in 3 years. And we should like go. I can like carpool you there. Like we can get use some new glasses or something. Okay.
Awesome.
All right. I'm not buying. That's not happening. But, okay. So here's the deal. Here's what I did. That's kind of goofy looking. So I plotted 8, -1 here, and I plotted 5, -2 here. Okay. So those are the 2 points they give you, and they say that one's a third of the way, right? So what I did is I did the distance going down 1 and over 3, because that's the distance between these 2 points, vertically and horizontally, and I did that 3 times. Smell what I'm stepping in? Right? That's dope, right? Now, if I just taught you, like, here's midpoint formula, would you be able to do this at all? No way. And maybe you didn't do this, right? That's fine. But the idea was there, right? When we did the front page, we talked about how we could do a triangle to figure out the midpoint, right? Well, you can do multiple triangles if you want to figure out a third of the points, right? Or a third of the way, right? Or to reveal the other endpoint. That's cool. Now, we're going to have a formula called the section formula, which we generally went over, right, the other day. We're going to go over today. That's going to give us the algebraic way to find this, which is nice because you can just plug in any numbers you want and get it, right? I was lucky that I had nice integers to work with, right? But what if it was like, this point is at root 5 comma pi? Like, oh, great, I'm screwed, right? So that's helpful. Thank you, Descartes. Did anybody get this last one? -1, -4 was the endpoint? No? It's okay, that was for self-development. Yeah? You got it? How'd you do it, cheater? Nice job. Nice job. She did it my way. Yay. I did it my way. Anybody name the artist My Way? Frank Sinatra. All right. Put that away. Let's get out the other homework. I get so much homework in here. So much. All right. Geometry. So this we're not going to grade today. We're just going to look over it. I was giving you a head start. What you could have done last night without any need for what we're going to do today, because we barely touched on section formula yesterday, is to graph each pair of coordinates, like plot them. Like you could do that, right? So hopefully you did that and got a head start. If not, oh no, you got to do it today. Connect them to form a line segment. Oh no, got to do that today. If you didn't do it, you got to do that. Find the midpoint and the distance of each segment. So you know how to find midpoint, you know how to find distance, right? What's the midpoint formula? Everybody. Very good. You don't need to say over 2, because average implies dividing, right? So the average of 3 grades, add them all up, divide by 3, right? That's an average. So you don't have to say divide by 2. It's redundant. All right, so, and distance formula we know as well, right? The distance between the x's, the distance between the y's, right? Distance is subtraction, and it's p-fag, right? Cool. Plot the midpoint on the graph. So after you find it, plot it, show all your work. So you could have done this whole first page, right? Turn the page. On the back, it says the same dumb thing, except it says find the point that divides the segment by the given ratio or fraction. Remember, we need to put it in ratio form first, because that's what m and n are. Remember that from section formula? We'll talk about that. And then plot that point, show all your work. So they ratio of 1 to 2. Before we're not going to go through this, but let's write that as a fraction just so we know what that should look like. Okay, we need this in this form because that's mn, right? M is 1, n is 2. Okay, but we should write it as a fraction to know what we're expecting. So 1 to 2. Again, if I get out cards and I start dealing, you get 1, you get 2, you get 1, you get 2, you get 1, you get 2. What's that going to be? How much of the deck does the person on my left get that I'm giving 1 to? Yeah? Half the amount of the other person. That's true. That's a weird way of saying it, but it's absolutely correct. So how much of the deck is that? What fraction of the deck is that? Nope. Because half would be 1, 1, 1, 1, 1, 1, 1, 1, right? A third, right? So we have a third versus 2/3. And just like you said, half of what they get is what they get, right? Well, what's half of 2/3? Well, if I have 2 chickens, what's half of that? 1 chicken. So if I have 2/3, half of 2/3 is 1/3. You just divided fractions. How could it be anything else? Okay, so that's what we're expecting, a third and 2/3, okay? Now, the way this is phrased, okay, A comes first, so it's going to be closer to A than it is to B. Does that make sense? Okay. 2 to 3. What's that in a fraction? Again, we want it in this form, so we don't need to change this. I'm just making you think. What's 2 to 3 in a fraction? You get 2, you get 3, you get 2, you get 3, you get 2, you get 3. What's that in a fraction? Think about it. Deal only, here. I got the parts. Hate that thing. Glad it's gone. All right. My parents just got their kitchen remodeled and I'm walking around and this is catching on stuff. I just like to hug the walls apparently. I'm learning that about myself. All right, so if I have 5 cards, because that's all we need to do a 2-3, right? You get 2. You get 3. How much of the deck is that? It's 2 out of 5, right? So it's 2/5. So we have 2/5 versus how many fifths? 3/5, right? The rest of it. Again, where do these numbers come from? The 2 and the 3 come from the top, right? What about the denominator? It's the total number, right? So it's when you add those all together is what the denominator is going to be, right? So 2 plus 3 is 5. That's a 2 out of 5. That's a 3 out of 5. Okay? Back up here. 1 and 2 make B. 1 out of 3, 2 out of 3. You dig? Not complex. That's how you convert between ratios and fractions. Remember, we need ratios for these types. Let's look at number 6. I'm still zoomed in, so I have to scoot. All right, so number 6 is presented as a fraction. We need to present that as a ratio. So if it's 4/7, and we want to make it a ratio, well, we need 7 cards. 3, 4, 5, 6, 7. How about you get 4, and you get 3, right? What's that as a ratio? 4 to 3, right? This can be a big brain stumper, right? Because you're like, oh, what do I do, right? But it's not hard. It's just you don't know. But now you do. And if you don't know, come see me, right? We don't want something that is not difficult holding you back because it's just you don't see it yet. It's kind of like puzzles where if you get them like real close to your face, right? When you get them real close and you pull them away, you can see like the hidden image. Okay. Sometimes it's hard to see things, not because it's hard, but because you just don't. And so you need somebody to help show you, right? That's why my grandfather showed me how to do those things, right? I thought at the time with my family that when he says, put this real close to your face, he was going to like slap me with it, right? But he didn't because he was a nice guy. All right. So that's how you do those, okay? You need to plug those into your section formula. Let's talk about section formula. So your notes from yesterday we kind of skimmed through, and skimmed is like a really nice way of saying it. We talked about midpoint formula and how that's calculated. Let me zoom out. Right, this first page is midpoint. Oh, by the way, if you weren't here earlier and didn't hear, no more color copies printed out for you guys. I'm sorry. I can do black and white if you really want them, but I would assume you'd rather have them on Google Classroom. They got me. They said no more printing them out. I'm like they calculated that out of the entire district. I print off 1/5 of all the color pages out of the entire district. There are 5 schools, right? So I'm like an entire school unto myself. Which I understand. You guys all want copies because it helps. But I can't do it anymore. I'm sorry. I wish I could. Okay? Or just have other teachers print them out for you and get them in trouble. How about that? I wasn't in trouble. Everything's fine. But all right, so section formula. We already know how to find the midpoint of a given segment, right? We can either do it algebraically or geometrically. Geometrically, find the half point here, half point there, connect them. Boom! There's your midpoint. And there's the algebra to go with it. Bless you. We talked about midpoint formula and section formula yesterday very briefly. This is the midpoint formula. Average of the x's, average of the y's. Section formula has m and n in there, right? And if you missed it in yesterday's lesson, m and n are here too. They've always been there. We just haven't seen them. The analogy I use is that Isaac Newton, right, this guy, the guy who basically invented calculus, again, one of the big 3 in mathematics. Whoop. We all good? Yeah, don't press those buttons. You're going to have the police come to your house like happened to me. I was putting my bed together when I moved to my apartment. I pushed it up against the wall. I'm like, where's my phone? And then a police officer knocks on the door. He's like, are you okay? I'm like, yeah. It's like, we got an emergency call. Turns out my phone was behind my bed, and I pushed it into the wall, and it jammed those buttons together to call the police. And I was like, yeah, that's not good. I don't know. It was weird because I just moved in, so there's like boxes everywhere, and I'm like running around, and it's like there's no heat, or there's no air AC, and this is like a 100-degree day. So he walks in, and it's like all like, you know, mist everywhere from all the humidity. It's like, hey, what's up, man? What can I do for you? Yeah, I didn't get arrested, so that's good. All right, so these two are the same. M and N are the same. They're always there. So Isaac Newton discovers gravity, or at least the equation to describe it, right? So Einstein says later, sorry, your equation isn't accurate. It only works for stuff that is like our size, right? Including like mountains and ants. But when you get really, really big, the things that were hidden become apparent. They start mattering, right? There's things that were so small in his calculations that they were negligible. He could not calculate them because he couldn't see them, right? But they show up when you have really big sizes like planets, right? They also show up when you go subatomic. And so those things start mattering. So when we do section formula, M and N matter. Midpoint, it doesn't, because this is when we do midpoint, we're saying we want a ratio of 1 to 1, right? That's what we're looking at. So when the ratio is 1 to 1, M is 1 to 1. Well, look what happens when I plug in 1 for M and N. What's 1 times x2? x2. What's 1 times x1? x1. Do you see how it just becomes this? And what's 1 plus 1 in the bottom? 2. Do you see how this is a nice midpoint formula? It's less to remember. It gets you the answer. So we'll call it a formula. But it's not the full story. You can divide it up however you want. You can divide it up 2 to 3, right? A 2 to 3 ratio. That means M's 2 and N's 3. In that case, we'd have a 2 here and a 3 there. So we have 2 y2s and 3 y1s. Now, why do we divide by m plus n? Well, here's why. If I've got a 2 to 3 ratio, we know that's asking for 2/5 versus 3/5, yeah? You gonna be okay?
Yeah.
Okay, you don't need help?
No, I was just talking about how I messed up the whole bunch. Made it way too low.
Yeah, don't mess with the margins, man. All right, so 2 to 3 is our ratio, right? And why do we divide by m plus n? Remember, this is m, this is n. Because, look, we have to divide it into fifths first. And then you take 2 of them and you take 3 of them. If I write out the equation, right, we have m, x1. Actually, let's do x2 first. Do x2 first always, okay? And then n, x1. So this is kind of weird, the formula. x2 comes before x1, but we're used to that by now, I hope, with distance formula and all the others. I've been preparing you to do x2 first. M and n, m comes before n in the alphabet, right? So it goes first. A lot of people teach it the opposite, where the 1 and 2 are switched, and then the alphabet's backward. I think that's more confusing. And then we do m plus n, right? And that's just the x coordinate. So you do the same thing with the y's. Right? But let's just focus on one side, because what's true for this side is true for that side. So when I apply a 2 to 3 ratio, m is 2, so I have this, and n is 3. And then when we add them together, we get 5, right, in the bottom. Same thing over here, just with the y's. So we're going to divide by 5 here, and the reason for that is if you have a segment, and you want to divide it up into 2/3 and 2/5 and 3/5, the first thing you should probably do is divide it up into fifths, right? So there's fifths. Ignore that. Okay, it's a little bit bigger. So if I want 2/5, I take 2 of them, and you take 3 of them. Right? So what we do first is we divide it up 5. This guy takes 2, that guy takes 3. That's the idea. Another way to think of this is good old Saddam, right? The balancing point is right in the middle. That's the midpoint. Okay? But what if this ruler wasn't evenly balanced? What if this side was heavier, right? If this side was heavier, the balance point is going to be more towards the side that's heavy. So check it out. This guy right here, the 2x squared, that's going to be the heavier side. It's kind of counterintuitive. You think the 3 would be heavier. But remember, he takes 3. So this is our x1, this is our x2, right? So he takes 3 of them. So the balance point is here. Now, if this is a ruler, which is the heavier side, the left side or the right side? If the balance point is here, which side has to be heavier, the left side or the right side? We have disagreement. So if the balance point's in the middle, it means it's perfectly balanced, right? Both sides are equal. But if the balance point's way over here, which side is this going to fall? It's going to fall to the right. Why? Because this side is not heavy enough to balance it out, right? So that's not the balance point. But if this was the balance point, this side must be as heavy as this side, right? Okay? So the answer is which side's heavier is neither. They're both the same. That's the balance point. Got them. Now, which side has more weight per inch? This side, right? Okay? It's got a lot more weight and a lot less space. Okay? That was a fun question, wasn't it? So this side is going to be the more weighted side. Honestly, they're both the same. But like this side has more weight and less space, right? So it's counterintuitive, but that's going to be the heavier side, right? It's okay. Keep doing you. I just was making sure we weren't like trying to summon a demon or something. All right, so here we are. So how many x's do we have here? Well, we have 2 x2s, right? And we have 3 x1s. How many x's is that total? 5 x's. So of course we divide by 5. That's the average, right? If we have 5 pieces, we divide by the number of pieces, right? That's section formula, guys. That's really it. So if we go to page 3, it says understanding ratios. We talked about this, right? 1 to 1, right? Down here we have 2/3 versus 1/3, right? Because the whole thing's 12, right? 8 out of 12 is 2/3. 4 out of 12 is 1/3. So our ratio is going to be 2 to 1, right? 2/3 versus 1/3. You dig? Okay. We've talked about that. Page 4, we do some more. 2 to 3 is a 2/5 to 3/5. A 3 to 4. What's 3 to 4? That's going to be 3 what and 4 what?
3/7.
3/7, 4/7, right? The total amount. Cool. seeing the connection. So M and N, those are the parts, and then the total is on the bottom, right? We've talked about that as well. And then we're back to here. Look, section formula. Now, why do they call it P here instead of M? We're on page 5. You're finding a point. But why didn't we call it M? Yeah. We're not finding a point. We're finding any point that you're looking for, right? Okay? Math sometimes does make sense. Now, could you call this G if you wanted? Yeah, sure. Who cares, right? But in order for it to make more sense and to connect with you, mathematicians are like, let's call it P for the point we're looking for, and M for midpoint. Does it matter? No. You're going to get your answer no matter what, right? There it is, okay? So we take our points, 2, 2, and 5, 5, and we plug them into x1, x2, y1, and y2. When we do so, it looks like this. Am I still zoomed in? Not really. Okay. So notice M and N are 1 to 2, because that's our ratio. We wanted a third of the way, so 1/3 versus 2/3. 1/3 versus 2/3. X1 and x2 are 2 and 5 from our problem, right? These guys right here. And then 2 and 5 again. Why did I mirror that? That's so dumb. I need to remake all of this. 2 and 5 again for y's, okay? I'm glad I used color here, because if I didn't use color, you'd be wondering which 2 did I put here, right? Silly. All right, so what do we get? 1, 5 is 5, 2 times 2 is 4, we add them together, we get 9, 9 divided by 3 is 3, right? Will you always get a nice number after you divide? No, right? Sometimes, if you want to find the quarter of the way through something, right, and it's 3 steps, you're going to get a fraction, right? You're going to get 3/4, and that's okay. Whenever we divide, there's always possibility of fractions, which is why we usually divide at the end. That way we don't get fractions and have to do other stuff with them, right? We'd rather it be the last step. That way, circle it, right? Put a box around it. All right, so here we go. So the point we were looking for is 3, 3. So if we graph it, you can even tell that it's a third of the way. That looks about a third, right? It looks about a third. And you can check this with triangles as well. There's 1 triangle, there's 2 triangles, there's 3 triangles, all the same, right? So that 2 triangles over here, 1 triangle over there, that's 2/3 versus 1/3. So visually it works as well. All right, another example. Everybody loves examples. Find the point 2/5 of the way between A and B. Well, 2/5 and 3/5 is a 2 to 3 ratio. Hopefully everybody's comfortable converting between fractions and ratios now. This blew students' minds last year, like in a bad way. They were just like, could not do it. I hope you guys can. 5, 10, 0, -5 are A and B. So A is the point they list first. We're going to assume, and we know that what this can do to us, right? It can, assuming, right? We talked about this at the beginning of the year. I'm going to have it on camera now, if you can see it. So assuming can make a out of and, right? But we're going to do it, and we do it a lot in geometry, and that's okay, as long as we assume safely and aren't afraid to be wrong. So we're going to assume that what they want is the point that's 2/5 of the way between A and B, meaning that it's closer to A than it is to B, right? So when we do that, x2 has to be B. That's the further point, okay? So x2 comes first, like it always does in all of our equations, okay? And m comes first because alphabet, right? So 2 and x2 come first, that's B. So 2 and 0 is 0. 3 and 5 is 15. So we get 15 over 5. Oh, nice number. And over here we get 20 over 5, which is 4. Again, a nice number. So that's the point that's 2/5 of the way from A to B, and it'll be closer to A than it will be to B. Cool? Now, if I ask for the other way around to find both points that are, 2/5 of the way, you got to do it in reverse. B would be x1, y1 in that case. You'd flip them. Questions on that? Okay? That's a lot of notes, but in general, it's not a lot of information, I don't think. I think it's just showing you examples and giving you space. That's why I was hoping we could squeeze it in yesterday with our extended warm-up. The hardest part, I think, is the ratios, right? So here's what I want you to do. Get out the homework with a partner and work on it. That's it for today. Look how much time we have left in class. Amazing. Like 9 whole minutes.